So page 145, permutations and combinations. So I think that permutation and combination might kind of look a little grayed out on your notes. I'm not sure, but just go ahead and highlight those words. Probably the most important thing past understanding how to handle a factorial, the most important thing after that with permutations and combinations is being able to identify which one of them deals with your problem situation. Because at this time, I'm going to give you the formulas for these things because they're so new and different. I think that you probably wouldn't have really that bad of a time remembering them and understanding which is which, because we'll talk about that. But at the same time, I can't guarantee you that you will always be given those formulas. If it comes up on something, if it comes up on the SAT, if it comes up on the ACT, whether or not you'll actually be given those formulas. I don't know the answer to that. If you get into a stats class, probably not. It's something that you kind of have to know, maybe. Again, I don't know for sure. I can tell you that I will, but past that, it's still important that you understand them. And if you don't understand them, that gave you a formula chart with them on there right now, you still wouldn't know what the heck to do with them. So you need to understand them and not just think, oh, well, if I'm just going to be given the formulas, it's no big deal. I don't even have to pay attention to them. So make sure that we focus on what's going on here. So we've got to decide, we have to understand the differences between a permutation and combination. So for a permutation, it's a set of objects in which order is important. Okay, order is important. Therefore, to a permutation, the trio of Brittany, Alan, and Greg is different from Greg, Brittany, and Alan. Okay? So Brittany, Alan, and Greg is different than Greg, Brittany, and Alan because the order matters. It's not just about which people is who, right? So a combination is a set of objects where order is not important. So the combination of Brittany, Alan, and Greg is the same as Greg, Brittany, and Alan. So it's combination is just grabbing three people. Permutation would be grabbing them in a specific order. You're my first place, second place, third place kind of thing. Now, I want you to think about this. A combination lock, like you're going to use in your locker in the locker room. Does the order matter on the numbers? Yeah. So if I know your combination, that's not going to help me any if I don't know what order I'm supposed to do the numbers in, right? I mean, I could eventually figure it out probably, but it matters. So even though it's called a combination lock, you do the combination of it. On a combination, when we're talking statistics, the order doesn't matter. It does on a lock. Okay, so sometimes people say, well, why isn't it called a permutation lock? That's something, if you cared to Google it, you will find things like that. But we'll talk about why it's not actually called a permutation lock either. Probably shouldn't be called either one. But all right, so let's just look at which is which here down this little table. So a permutation versus a combination. A permutation would be picking a team captain, a pitcher, and a shortstop from a group. So I'm picking specific spots for these people. A combination would just be picking three team members that are going to go out there and do whatever. Permutation is picking your favorite two colors in order from a color brochure. Pink is my favorite, blue is my second favorite. Or just picking two colors. I'm going to pick pink and blue. This is what we're going to use. Permutation is picking first, second, third place, and then combination would just be picking three winners. So if I was going to do some sort of drawing and I just grabbed three names and said, hey, these are my three winners, that's a combination. Permutation would be the first place, second place, third place. Does that make sense? You see the difference between the two? One of them order matters, one of them does not. So up here, it says permutations are picky. Permutations are picky because order matters, right? All right, so your formulas look like this. It says a permutation, so go ahead and highlight permutation, maybe highlight something else too, is a set of n things. Are they not sharing with you? Share with her. Are there not enough on there? Okay. That's okay. Not a part. All right. A permutation is the set of n things. So n is the total number of things taken r at a time. R is also a number, but it's the number of things we're using. So if I was going to pick a first, second, and third place winner out of the group of y'all, then N is the total number of people in this room. R would be the 3 because I got a first, second, and third place. Okay, but it's taken at a time without replacement and where order does matter. This is the other thing I want you to highlight. Order does matter. So for a permutation, order does matter. That's one of the most important things for you to get out of that. Combination, we'll fill in the formulas here in a second. A combination is a set of N things, also taken R at a time. So N is the total number, R is how many I'm using at a time, and again, without replacement, and where order does not matter. And I want you to highlight, order does not matter. So let me ask you about this. If you were going to think about a combination lock, could you use the same number twice in a combination? Yeah, you could. So both of these are without replacement, which technically means it's not a combination lock or a permutation lock. So we should just have a totally different name for it, but don't try and equate it with this because that's where some confusion falls in. Okay, so here's what the formulas look like. Permutation, there's a capital P. Combination, there's a capital C. Okay? The N and the R are little subscripts for the P and the C. So N goes on the left, R goes on the right for both of them. So it looks like that. So this is a permutation of N things taken R at a time. This is a combination of N things taken R at a time. So that's the notation of what's happening. Then for a permutation, the formula looks like this. It is N factorial divided by N minus R factorial. See why we did some problems like that yesterday? It was going to look like that. Now, the combination formula looks very similar to that. It is N factorial on the numerator, so the numerator is exactly the same, but we just add something in the denominator because it is R factorial times N minus R factorial. So I want you to think of something. If I was going to think about permutations and combinations, and I'm going to use the same N and R, even the same situation. Let's say I'm making like a seating chart. Okay, and I'm going to do a permutation to sit y'all down, or I'm going to do a combination to sit you at your table. What do you think has more possibilities, a permutation or a combination? So when I make your seating chart, usually I just say, I put you up there and you're in a specific order, but then I say, I don't care where, as long as you're at that table, I don't care which seat you sit at, right? So technically, then that makes that just a combination because you're just a group of 4 people and that's just how it fit on my paper. You with me? Okay, so that's a combination. Permutation would be when I say, no, your seat is here and your seat is here. So if I wanted to change your seating chart permutation-wise, I could just mix up the order in which you're sitting at your table without you actually changing tables, right? Where a combination, it doesn't matter how you sit, you're just a group of 4, right? So permutation, now how many different ways can 4 of you sit at one of these tables? 24, right? So without you even changing tables, I can change it up 24 different ways. And then I start moving your tables, that's even more and more, right? So a permutation is going to have more possibilities than a combination because the order does matter. It's not just 3 people. It's 3 people in first, second, and third place, right? And then maybe I could change up their order with still using the same 3 people. So with that thought in mind, permutations have more. And if you look at these 2 little fractions, the only difference between the 2 is that combination has something extra in the denominator, which means I'm dividing it out more, which means this number has to be smaller. Does that make sense to you? So then you'd have less possibilities there. Okay? Any questions at this point? We're going to look at how we decide this and what we're going to do with it and all that stuff. But all right. Now, there's some special cases down here. Don't even worry about these. I put them on here. I mean, there's always a couple people that really likes probability and statistics stuff and it makes sense to them and they're good at it and they kind of see these things happening within what they're doing. But we are not going to get deep enough into this for some of these to even really click with you, and that's okay. The best thing for you at this time is don't worry about the special cases, because you might try and use them at the wrong time and they may not make a whole lot of sense to you anyway. If you use the formula itself, it'll all work out even if it's a special case. Does that make sense? And it's probably safer for you so you're not thinking about it wrong. Any questions at this point? Probably don't even know what to ask yet, right? I understand. It's all good. All right, so let's look at this part. It says, questions to determine combination or permutation, because that's the first thing you have to decide is what is it and then what am I going to do with it. Remember that N is the total number of things, R is how many you want. So when I'm making a seating chart, there are 24 of you, but I'm going to take you 4 at a time to put you in little groups. Make sense? So first of all, does order matter is the first thing that you ask yourself. If the answer to that is yes, is it a permutation or combination? Permutation. If it is no, that means it is a combination, right? Then you figure out how many total objects do I have. That is your N. And how many things are being taken at a time. That is your R. So these 3 questions right here need to be answered before you start trying to plug anything into anything. All right. Everybody good? All right, now I want you to look at the next set of stuff, and it says, are the following a combination or permutation? So I want you to read through these 5 things and just put a P or a C next to it after you decide whether or not it is a permutation or a combination. All right, so let's see. Who's going to help me out here? All right, so the first one, Jonah, choosing 5 students from a class to work on a special project. Would that be a combination or permutation? Combination. Y'all agree with him? Yes. Okay, good. Now, I could change this a little bit to make it a permutation. How do you think I could change that to make it a permutation? Anybody? Giving them specific jobs, exactly. I'm going to choose a person that's going to write, a person that's going to draw the pictures, a person that's going to, if they have specific jobs that for this project, then that would totally turn it into a permutation. Okay, so just think about those things. I can use these exact same problem situations and change the question just a little bit, and it can change it from one to the other, from permutation combination. So don't think just because it's always a group project that it's a combination. All right, good, thank you. All right, so then the second one, Adriana, arranging 5 slides in a PowerPoint presentation. What do you think? Permutation? Do you agree with that? Yes. Okay. So arranging them means that it's a permutation. If I'm just going to pick 5 that I'm going to throw in there because they're pictures and I don't care what order they're in, then that would be a combination. But this definitely, because you're arranging them, is permutation. Good. Thank you. All right. The next one. Ileana, being dealt a hand of 5 cards from a 52 deck of cards. Combination? You okay? Y'all agree with that? Yes. Okay. Because it's not in any specific order. All right. Arranging the letters in the word algebra. Pearl. Sorry, what? Permutation. Y'all agree with that? Yes. Good. Because again, we're arranging them. We're not just picking letters from alphabet soup or something. All right. And then checking out 3 library books from a list of 8. Sebastian. Combination. Y'all agree with that? Yes. We're not like picking winners of a book contest or anything. All right, so everybody okay with that? You just see, that's just deciding which one it is, and then we'll go from there on what to do. Any questions? All right. So this says the manager of a baseball team has to select the 9 starters for a game. She has 11 players to choose from. How many combinations of 9 players can she choose? Permutation or combination? Combination. It kind of gives it away. You don't always get that lucky, but it says combinations of 9 players. So it's kind of right there. But I'm just picking 9 players. It doesn't say that she's giving them positions or anything, just picking 9 people. So it is a combination, which means there's going to be n things taken r at a time. So that is n factorial divided by r factorial times n minus r factorial. So there's my combination formula. So then I have to decide with this C, what is my N? 11, because that's the total. How many people am I going to use at a time? 9. So there's my N, there's my R. Then I can plug it into that stuff over there. That's going to give me 11 factorial divided by 9 factorial times 11 minus 9 factorial. Everybody all good so far? What's the first thing I have to do? Parentheses. So this is going to give me 11 factorial divided by 9 factorial, 2 factorial. Then what do I do? Okay, start writing out the one on top. 11 times 10, when do I stop? At 9. You stop at the biggest one on the bottom. It doesn't always necessarily have to be the first. And then that's going to give me over 9 factorial, 2 factorial. Then what happens? The 9 factorials cancel out. So this gives me 11 times 10 divided by 2 times 1. So the 2 can reduce with the 10. My answer is 55 combinations. Everybody good so far? Any questions? Alrighty. So then it says the manager of a baseball team has named the 9 starters for the game. She needs to determine the batting order. How many batting orders are possible? Is that a permutation or a combination? Permutation. Okay, so it's a permutation, which means we're going to have n things taken r at a time. So that's going to give me n factorial divided by n minus r factorial. So before we even start this problem, I want you to just write a number down over here. Take a wild guess as to what you think a reasonable answer might be for that or where it might be. Just ballpark it like we did yesterday. It's okay to be way off. It's just kind of see if you have an idea of what's going on. All right. So then I've got to decide n and r here. So what is n? 9. What is r? What is r? 9. Right? Now, why am I not using 11 for the n? Didn't say 11. Even if it was the same one up there, even if it was the same baseball team from above, it says she's already picked her 9 starters. So since she's picked the 9 starters, the fact that there was 11 people to begin with doesn't matter because we're only using these 9 are the ones we're using. And they all get put in the batting order, right? So sometimes n and r can be the same number. In this case, they are. So that means that this is then going to be 9 factorial divided by 9 minus 9 factorial. So what's 9 minus 9? 0. So I get 9 factorial divided by 0 factorial. Does that mean it's undefined? No. What is 0 factorial? 1. So this is just 9 factorial. Now, this is one of the special cases. But again, that's kind of irrelevant because I wouldn't stress out over it. If n and r are the same number because you're using all of them, then it is just n factorial. Okay? Oh, no, we're not done. You can need an actual number, yeah. But what I'm saying is there's not really, like you could kind of skip to that point if you knew it was a special case, but I don't know that we're always going to identify them and remember what they are. It's better just to do it because I'll give you this formula, but I'm not giving you the special cases. All right, so 9 factorial means that it's 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, are you capable of multiplying that out by hand? Yes, you may not enjoy it and not want to do it, but you're capable, right? And I'm not going to make you. But we are going to talk about, again, working smarter and not harder. If you've got all this separated out, you're in control of what order you multiply in. So starting from here and multiplying 9 times 8 and then multiplying it by 7 and then multiplying by 6, I don't know that that's necessarily the best way. There's nothing wrong with it. That's not the way I would choose. If you understand how all these things relate, if you think about it, what is 5 times 2? 10. So I'm going to take those 2 out of the mix because I can figure out everything else, and then I'm basically just going to add a 0 on the end because 5 times 2 is 10. Does that make sense? So I've taken a couple of them out of there. And then maybe I want to multiply 9 times 8 and get 72 and then get 12 here and 42 here, and that can multiply the 42 times the 12, and then by the 72, or whatever order. On the homework, the 10 factorial, I saw a lot of good things, like people actually thinking about what they were doing before they started. And if this was 10 factorial like it was on the homework, then I could take out the 2 and the 5 and the 10. Then I got 100, and I've taken all that out of that mix. But you had already done on number 1, 7 factorial. So if you knew what 7 factorial was, then it's really just 10 times 9 times 8 times 7 factorial. You already had that number. You take the 10 out because that's easy. You got 9 times 8 is 72. You really just need to take that 72 times whatever number you already had and then add a 0. Does that make sense? And so instead of always just starting and doing random math everywhere, think about what you're doing and you can simplify things for yourself greatly. Okay? So the answer to this in the end then is 362,880 batting orders. Yeah, so anybody get anywhere close to that? You got 9. Well, does that answer seem a little ridiculously high? I think it does too, and it does, and that's why I wanted you to take a wild guess, because I wanted you to see that, I mean, 55 wasn't that bad, and that was our combinations, and that was a little bit different anyway, but this seems outrageously high, and obviously a baseball coach is going to take more into account than just any possible order that they could do. You know, they know who needs to go first, who needs to go last, those sorts of things. Yes. Yes, and I was actually about to get to that, so that's a very good question. So I've got 9 people, and all 9 of them are getting used, but it only works because all 9 of them are getting used. That's why. So her question was, why do I need to do this? Can't I just use the counting principle thing we talked about yesterday? And yes, and that was another thing I was going to show you. We've got 9 spots to fill. 4, 5, 6, 7, 8, 9. 9 spots to fill. Since I'm filling all 9 of them, and I'm using up all 9 people, then that is totally the exact same thing. When I'm not using up all the people is when I absolutely have to use this. Does that make sense? So I do think I'm using all 9 of them. When I go to pick my first person, I have 9 people to choose from. Then that person's number 1. Then I have 8 people. Then I have 7. Then I have 6, all the way down. And that is the, how do I arrange them, and the kind of thing that we talked about yesterday. And that is this exact same thing as 9 factorial. So that's why on that one, and that's why this is a special case, really, is what it comes down to. It is just a special case because you can use this. But if I had 9 people and I was only putting 7 of them in the batting order, then I would need to do it the other way. Does that make sense? That's a very good question. But again, the coaches take into account, who needs to be first, who needs to be last, those sorts of things. Now, if you're coaching 5-year-olds, then it probably really doesn't matter that much, and you really do have this many options. But I would be willing to guess that a lot of baseball coaches or softball coaches don't even realize that they actually technically have that many options, because it seems ridiculously high, but it is the correct amount. Okay, questions? So, reasonable 7 answers a little bit difficult here because some of them do seem outrageously large. All right, any other questions? Example 4. There are 33 cars in a race. The first, second, and third place finishers win a prize. How many different arrangements of the first 3 positions are possible? Permutation or combination? Permutation, because I'm picking first, second, and third. I'm not just picking 3 winners. So it's a permutation, which would be n things taken r at a time. So that is n factorial over n minus r factorial. All right. So what is my n in this case? 33. What is my r? 3. So then I go and plug that in. That's equal to 33 factorial divided by 33 minus 3 factorial. So then that's going to give me 33 factorial divided by 30 factorial. So then I start to expand the numerator. 33 times 32 times 31 times 30 factorial over 30 factorial. Then I divide them out, and I'm really just left with 33 times 32 times 31. and that gives me 32,736 different arrangements. And why gambling is not a good idea. Because if you're betting on NASCAR, they got 43 cars in the race, not 33. And really the only person that matters is the first place winner. So that makes it even worse. Okay. Any questions? We're all good? That's just the first three. That didn't even include 4 through the rest. Because if we did want how many different ways could the 33 cars finish, and we're talking about all of them, then that's just 33 factorial. And that's a whole lot more. So I'd still take this and multiply it by 30 times 29 times 28, I mean, it's outrageously large. We all good? Okay. All right. Next one. Special combo pizza at Ciro's Pizza includes any 5 toppings from the list of 16 toppings. How many different combo pizzas are possible? All right, I'm going to give you a few minutes to work this one on your own. Think about combination or permutation and work it out. Okay, so we've decided that it is a combination. And again, if you had started with permutation, then you don't have to erase everything. It is a combination that's n things taken r at a time. So that is n factorial divided by r factorial times n minus r factorial. Okay, so what is n in this case? 16. What is r? 5. Because remember, the order in which we choose the toppings doesn't matter at all. So that's going to be equal to 16 factorial divided by 5 factorial times 16 minus 5 factorial. So that's going to give me 16 factorial divided by 5 factorial, 11 factorial. Everybody with me so far? Okay. So then that's going to give me 16 times 15 times 14 times 13 times 12 times 11 factorial. And remember, you work it out until it matches the biggest one in the denominator. You can work it out to the smallest one and go that way, but you're really just making more work for yourself. So I get there. Now I have stuff I can cancel. Then I rewrite this, and I get 16 times 15 times 14 times 13 times 12 all over 5 times 4 times 3 times 2 times 1. Then I start to reduce. Okay, now, how exactly you reduce is not really that important, but I'm going to just kind of give you some helpful hints here. The 5, really there's only one thing that I can reduce the 5 with. 15, so that makes that 3. I can reduce the 4 with the 12 or the 16. And I know 3 times 4 is 12, so I could just knock that out. But I'm going to take the 4 and reduce it with the 16. I'm going to take the 3 and I'm going to reduce it with the 12 to get 4. Now I'm going to pause here for just a second because I noticed something as the day went on when I was having people help me work these problems. I know we can reduce the 2 with the 14, and we're going to, but we got to a point yesterday where the problem, like, let's pretend that 14 wasn't there, and so you can't reduce the 2 with the 13. So some people were stopping there. They left it as a fraction, multiplied it all out, and then divided, which is not wrong because we still got the right answer. But it is okay to take this 2 and reduce it with that 4. Like, you can reduce it all, you can keep knocking things out even though you've changed it. So I would say always reduce it as much as you possibly can. But I would also say, even though 3 times 4 is 12 and we could have knocked that out, it actually puts you in more control if you reduce with as many different numbers as you possibly can. So even though I can reduce the 2 with either one of these 4s or the 14, I'm going to go with the 14. Because then that gives me more smaller numbers to choose from. So I'm left with 4 times 3 times 7. I can't forget the 13 that's buried in my work there, times 4. Now that it's split up like that, I'm in control and as far as what order I'm multiplying in. So whether I want this 3 times 4 to be a 12 and then do 12 times 13, or maybe I wanted to do the 21 times 4, you can kind of think about that as far as what's easiest for yourself. But we can do 21 times 4. What's 21 times 4? 84. So all that together gives me 84. And then what's 13 times 4? 52. So then in the end, I'm really just multiplying 84 times 52 instead of multiplying 5 times and just getting my number bigger and bigger. Anybody want to give me what that is? Good. 4,368 different combo pizzas. Everybody okay with that? Now, we don't have the list of the 16 ingredients, but if we did, then I could say, all right, you're going to choose 5 ingredients, but you have to choose 2 meats and 3 veggies. Does that change it to a permutation? No, because did I say what order you had to pick them in? No, I don't care if you pick a meat, then a veggie, then a meat, then a veggie, yeah, or, which one's your favorite, it doesn't matter. So it's not a permutation, but it's also not a straight up combination because I've given specifics, right? Basically, it's 2 combinations together, and that's what we're going to look at in this next problem and kind of what happens. So this next one says, there are 12 boys and 14 girls in Miss Schlutsky's math class. Find the number of ways that this lady can select a team of 3 students from the class to work on a group project. So let's just pretend that it stops right there. The number of ways she can pick 3 students to work on a group project. If I stop right there, is that a permutation or a combination? Combination, because I'm just picking 3 people. But then it goes on to say, the team is to consist of 1 girl and 2 boys. Does that change it to a permutation? No, it's still a combination because I don't care what order they're in and who's doing what. That's going to be up to them. It's still a combination, but I can't just say I'm picking 3 people because I have specifics. It's actually a combination of combinations. So I've got girls, right, and boys that I have to choose from. And I know that I'm using a combination, so I'm going to write that over here. Combination of n things taken r at a time. That's n factorial over r factorial times n minus r factorial. So for the girls, it's a combination. How many girls are there? 14. And how many am I choosing? 1. For the boys, how many boys are there? 12. And how many am I choosing? 2. So basically, I'm going to take these 2 things, and I find those 2 different combinations, and then I multiply them together in the end. So for the girls, using these numbers, the combination of 14 taken 1 at a time. So that's n factorial, 14 factorial, divided by r factorial, which is 1 factorial, times n minus r, 14 minus 1 factorial. Everybody with me so far? And then I need, this pen. Break my teeth. I don't know why it thinks I'm doing it. All right. So for the boys, that's going to be 12 factorial divided by 2 factorial times 12 minus 2 factorial. Everybody with me so far? So, and then I'm going to multiply these. Does multiplying come before or after the factorial? After. Order of operations, it comes after. So I'm going to treat each one of these separately and then multiply them at the end. So that's equal to, starting with this first one right here, 14 factorial. What's 1 factorial? 1. So is this even relevant to me right now? No. All right, then 14 minus 1, which is 13 factorial. Times, then I got to take care of the boys, 12 factorial divided by 2 factorial times 10 factorial. Once I can write it. Everybody with me so far? Equals, then I can start this right here. This is going to be 14 times 13 factorial divided by 13 factorial times, using the second one, 12 times 11 times 10 factorial divided by 2 factorial, 10 factorial. Everybody with me so far? So these 13 factorials cancel out, and the 10 factorials cancel out. So then that leaves me with 14 times 12 times 11 over 2 times 1, because that's my 2 factorial. Then I can reduce this and get 6. So what I end up with in the end is 14 times 6 times 11 which I can look at as 14 times 66. And that is going to give me 924 different teams. Okay. Everybody okay with that? Any questions? All right, so make sure you're correctly identifying permutation or combination before you start.